Hello, welcome to the Teal Engineering 1100 milestone video. Let's meet the team and explain the division of work.
Hi, I'm James Bowden, the group leader for Team Teal. My role for this team is to manage, delegate and communicate jobs amongst my team. For this project, I designed the structural subsystem.
Hello, I'm Sterling Lever. I've assisted the group in many aspects such as ideas and in part selection. Along with Cooper, we have designed the fluid delivery subsystem and assisted in the creation of the structural subsystem.
My name is Felix Pountney, and I am also from Team Teal. For this project, I have been a part of the power and control subsystem. This has involved working with a variety of other subsystems to power our remote firefighting vehicles safely, as well as coding an Arduino to allow control from any Bluetooth device. Along with this, I've also helped with hosting meetings and other day-to-day tasks for this project.
I'm Cooper Lewis, and I doubled up with Sterling in designing a fluid delivery system for the vehicle. I also conducted the risk management assessment for the prototype vehicle and created a CAD model of the vehicle using Fusion 360.
Hi, I am Ben Hyson. Myself and Praneet designed the drive subsystem for this project. As well as implementing the drive components, I also helped with the power and control subsystem to effectively control the motors of the vehicle.
Hello, I'm Praneet Dhulia from Team Teal. I, along with Ben, visualized and fabricated a sustainable drive subsystem for the prototype. I also assisted James in the manufacturing and fine-tuning of the structural subsystem.
With the introductions out of the way, let's talk about the specific details of each subsystem.
The base plate of the structural subsystem is a 300 by 190 by 3mm sheet of acrylic with two longitudinal 25 by 25mm square aluminium beams below it. These materials provide the durability and structural integrity to distribute the weight forces equally of all the components. This structural concept was designed within set parameters and required the integration of all the subsystem's components in order to create a functional vehicle.
The fluid delivery subsystem bolsters a 500 milliliter water storage tank, an immersible water pump which supports a voltage range between 4.5 and 12 volts, which will be the main method of water elevation and control. The system is then positioned with an M260 hobby motor capable of rotating the motor to any position in preparation to extinguish the blaze, and water is then transferred between pump and nozzle via a clear vinyl tubing.
Our team was successfully able to collaboratively work together and complete a design for the project's design phase. This was achieved through consistent team meetings via PBL classes, Zoom and workshop meetings every week. The consistency in regular team meetings allowed group members to share any questions, research and ideas that would benefit from a discussion. In these meetings, we were also able to discuss proposed budgets for aspects such as price and weight. Discussing these budgets allowed the group to better distribute in accordance with each subsystem. An example of such would be the specific collaboration between the drive subsystem and power control subsystem. Early in the project, Ben determined the expense of the drive subsystem would be the lowest, whilst Felix determined power and control would be more expensive. This was easily overcome by merging their budgets, allowing for a much easier cost distribution. Thereby, each team member effectively integrated different designs of subsystems to collaboratively propose a first concept vehicle.